So here is the pinout diagram of the Arduino board. I took it from the Arduino website Uno R3. So what we are interested here is we will try to glow an LED from pin A0. So let's zoom into it. So pin A0 has also something written as PC0. So what PC0 actually is, it is the port C of Atmega 328P. So Atmega 328P is nothing but the microcontroller of the Arduino board. A0 is the pin on the Arduino board and PC0 is the port on which that the pin is connected, the port of the microcontroller. So Arduino, so the Atmega 328P has multiple ports. In the Arduino Uno, we have three ports: port B, port C, and port D. So how does the microcontroller actually interact with all these ports? It interacts with those via addresses. Okay, so I have this address mapping. I took it from the Atmega 328P datasheet. So here there are three registers. We can see data registers, direction registers, and input pin addresses. Since I'm just glowing an LED from A0, I'm not interested about the input pin addresses. The only two registers I'm interested here is, the two addresses I'm interested here is the data register and the direction register. So what the data and direction register actually does, in the data register you put the data on which pin you want to glow, and in the direction registers we mention which pins are we want to be input pin or the output pins. For the input pins we need to initialize them with 0, and for the output we need to initialize them with 1. So the PC0 or the A0 which we are interested is this, the one circled here. So right here we have the coding part of the thing. So we're gonna start with using a volatile character. We are initializing the direction. We are gonna manipulate the direction registers. As I mentioned before, the direction register could be 1 for output and 0 for input. So what we want here is we want the reason I'm using a pointer here, pointer dir, because if we don't put a pointer there, then what the basic compiler does is it allocates a address randomly. So when we put a pointer there, then we have the control over which address we want. So with that dir is equal to 0x27, this hexadecimal address, and 0x27 is nothing but the address of the direction registers as seen before. So what we want to do here is we want to make the value of this to 0xff. So 0x ff is nothing but uh, when we put 0xff in hexadecimal, in hexadecimal is 1111 space 1111 in binary. So what we're doing is we are putting the 8, we are initializing the 8 registers we have as output, because we're gonna glow LED on that, as the port C address is 0x27 and we want all the pins on that port to act as an output. That's why we're going to put 0xff. So now coming down to the loop section where we want to put the value or the data in that. So again volatile, again we're going to do a pointer, make a pointer over here. So we have the control over the address out equals to 0x28, because that's the hexadecimal address of the data registers, and the value I want to put here is equal to 0x01. So what this is going to do is this is going to glow the first LED. 0x01 is nothing but 01 is turning on the LED at PC0 according to the microcontroller, or A0 according to the board. So yeah, we're gonna compile this code. Just gonna upload the code now. As you can see, the LED is glowing right now. It will be somewhere on the screen. So Arduino has 6 analog pins ranging from A0 to A5. The corresponding port on which they are connected is PC0 to PC5. So the data in binary and data in hexadecimal is this. For PC0, since I only wanted to toggle A0, the data in binary is 5 times 0 and a 1. In hexadecimal, it will turn out to be 0x01. For PC1, it would be 4 times 0 and 1 and 0. In hexadecimal, it would be 0x02. Similarly, you can go for other pins also, and you can just to convert the binary into hexadecimal and put the value in the code, and the pins would be toggled up.